All right, folks, welcome to your Dead Reckoning overview. As you guys hopefully should remember, you have your list of 12 steps that you're used to going through. But this big, huge piece of paper is not super helpful in the airplane, especially when you need to do multiple legs. That's where this guy comes in. It's called a VFR cross-country navigation log. It's basically like a Dead Reckoning cheat sheet. For today's example, we're going to be going over what what you guys are going to have on the worksheet in front of you now as your example, so you can follow along, see how I'm doing things. This is going to be our leg from the Carlton VOR up here, which you can find about 10 miles southwest of Detroit Metro, down to Adrian, which is 40-ish miles southwest of Detroit Metro. So in your leg section, you can go ahead and write in CRL, and then you can just write dash ADG. Cool, yay. Next thing is going to be our desired altitude. This one's going to be fairly straightforward. This is going to be a given for you. So in this case, it's going to be 6,000 feet. In today's example, we're going to say the wind is 360 at 17 knots. So for our true airspeed and distance, we're going to come up with a desired true airspeed. In our case, we're going to want to aim for around 100 knots, but we don't get to just say, hey, it's going to be 100 knots. No, when you have this magical performance chart in front of you, you're going to go ahead and use that. We're also going to assume for this example that we're going to be at standard temperature. So we find this center area that says standard temperature. We're going to be cruising at around 6,000, so we're going to go ahead and come down to our 6,000 tab. We want to be around 100 knots, so what are we working with? We have, there we go, there's 101 knots true airspeed, and that is going to get us 7.4 gallons per hour. So you come on over to your nav log. Your true airspeed is going to be 101 right there. And your fuel burn is not actually going to go in here anywhere, but you just keep that in mind, and we can just kind of write that up in the top corner, 0.4 GPH. Yay! All set. Now that we've written down everything we've been given, we move on to the stuff that we need to either measure or calculate. We're going to start with the stuff that we can measure. Why do math before you have to do math? As I always say. I don't know that I've ever said that before, but I'm rolling with it now. I don't have my plotter on me at the moment, so we are going to just use this ruler to start by just drawing out our line. Remember, when you have the VOR, it's nice and easy because there's a dot in the middle that you can make sure you line it up with. When you have an airport, be careful to make sure you measure to the center of the airport. Not the top edge, not the bottom edge, not somewhere stupid in between. So we're going to measure from the center to the center. We're going to start by striking a nice, clean, straight line. You can use whatever you want for this. If you want to be right and proper, a pencil is a good way to do it. I know a lot of people really like to use red pen. That's not a bad idea. So go ahead and strike your line for your start. Next thing you're going to do is you're going to go ahead and measure your leg. Take a moment to take a stab at that. Write down your answer, see how you did. For your distance, you should have gotten 30 nautical miles. If you got 15, if you got 60, you're measuring using the World Aeronautical Chart scale. Don't do that, try again. If you got something else goofy, you're probably measuring in statute miles. That's goofy. Do it again.
But better.
Next up is your true course. As a reminder to yourself, it's a good idea to put a little arrow to show which way you're going on the leg, or some people also like to do a little airplane. That works too. That's kind of fun. Either works, little arrow, little airplane, it's all groovy. Set your plotter on down, twist the thingy, make sure that all those parallel lines line up nice and clean and parallel with those lines of latitude and longitude. Then just read under the arrow where it's going. Again, sorry, I don't have my plotter. I'll do better. But in the meantime, I can tell you that what you should have gotten for your true course should have been 249 degrees true. At that point, it's just a matter of filling out your nav log with the new information that you've got. So under true course, that's the top up here. We can go ahead and write in 249 degrees. And for our distance, we can go ahead and write in 30 nautical miles. It's a good idea to write your units in at least the first line. Then as you go down, you can kind of know, but units are always helpful. Next part's the fun part. Pull out your E6B. We go ahead and set that aside. First thing we're going to do is reference our wind. So our wind velocity, we'll get that in frame. There we go. Should have been 360 at 17 knots. So what I'm going to do is in my true index, I'm going to go ahead and set up 360, which is north, right at the very top. And I'm going to slide my little grommet all the way down until it's right on top of the 100. That's what you should see right there. Next thing I'm going to do, since our wind is at 17 knots, I'm going to go ahead and go up from 100 by 17. So what's 100 plus 17? I sure hope at this point you can all tell me that's 117. So I'm going to go ahead and go up. Keep in mind that these scales are not always the same. Sometimes they're a little bit weird. On mine, it looks like each tick mark is 2 knots. Yours, it might be 2.5. Other people, it might be every 5, depending on what your scale is. My case, it's going to be 2. I think it's going to be 2 on most of yours as well. So we go up to 110. We know it's between 110 and 120, so that's 112, 114, 116, 118 is above that, so we can go ahead and go right in between that. Now you can use your marker or a pencil. Either works. It's just fine. Please, please, please don't use something you can't erase. Don't use Sharpie on my E6Bs. Then from there, from your line, draw a line straight back down to your grommet and draw yourself a little arrow. That tells you where the wind is coming from. Once you have your wind set up, that's when the fun can begin. You get to play astronaut and use a whiz wheel. So, next thing we're going to set up is our true course of 249 degrees that we're going to pull straight from our nav log. So we go ahead and set that up. Go ahead and give it a twist.
Twist it!
All the way until our true index is set to 249. That's 249 degrees. Just like that. Then what we're going to do is we are going to slide the fun part of our E6B until the tail of that arrow, not the front, otherwise we didn't do anything, until the tail of that arrow lines up really nicely with our true airspeed, which remember is 101. And we should get something that looks about like that. From that, we can measure. If we take a look, the length of that arrow is going to tell us how far we need to correct and in which direction. If the arrow is off to the right, we need to correct to the right. If the arrow is off to the left, we need to correct to the left. I realize at this point in the year, pretty much every single time, I've given you a correction to the right. No, I don't know why. It just happens to be how the wind has been playing. But in this case, I think the tail end of that arrow is exactly in between the second to last tick mark, that last tick mark before the 10 and the 10. So looking at this, it looks like we go by 2, 4, 6, 8, 10, 2s again. So that means our wind correction angle is going to be 9 degrees to the right. It's plus right minus left. So in our case, our wind correction angle is going to be plus 9 degrees. Please write plus 9 degrees. Don't just write 9 or 9 degrees. Please write plus 9 degrees so you can keep track. You will have an easier time. Next thing that we pull from the E6B is going to be our ground speed. Once we've set this thing up and done our spinning, the center of that grommet is going to be pointing at a number right in the middle. In my case, that looks to be 106 knots. Please focus. There we go. So that's going to be 106. And that goes under the section that says ground speed. 106 knots. Magic.
Why must I do math? WHYYYYYYYY.
Niner plus 9 degrees, so 49 plus 9. That should be 258 degrees. Now that we've calculated our true heading, we can start playing around with the stuff that, well, where it gets kind of weird. Cause, say it with me kids, magnets are stupid. That's not true. Magnets are pretty great, and let's not speak down upon them when they are not around. Also, they're always listening. They're in your phone. Be smart. Our magnetic variation, remember, because the Earth is wobbly and weird and there is not a consistent amount of ferrous elements, that's iron for all you nerds out there, there's not a consistent distribution of magnetic material throughout the entire, whatever of the Earth. So, our magnetic field's a little bit different. It wobbles a little bit, right? Our magnetic variation tells us how to account for that. In our case, there's a nice magical line that's dashed magenta with a label on it. We call that an isogonic line, isogonic. And that runs straight through our course, and it says 7 degrees west. Now, again, check your cheat sheet. West is plus, east is minus. Some people remember it as west is best, east is least. Whatever silly mnemonic device you would like to use, go for it. If it works, it works. I have no judgment. I have a little judgment. Don't do nothing stupid. Judging. Okay. So our magnetic variation, and I even gave you a little cheater right there. It even says minus east plus west, is going to be 7 degrees west. So rather than writing 7 degrees west and confusing yourself, you know it's plus. So just friggin' write plus 7 degrees. Don't have to go too crazy. The next stage of things is to deal with our magnetic deviation. Now, this is caused by the weirdness of your compass installation, all of the extra metal stuff in your airplane, throwing off the magnetic fields, messing with the vibes. So if we take a look at our wind-corrected course, so if we do 258 plus 7, that gets us 265, we are going to find the cardinal heading on the top. If we remember, we've got a 4 up here on the top, and a steer. Second line again, 4, steer. Meaning, if you want to fly perfectly north, you need to steer 1 degree to the right, plus 1. If you want to fly exactly, let's find another weird example, east, got to point it 1 degree to the left to 089. So, we find the one that is closest to our magnetic heading after we've corrected for variation. So again, 258 plus 7 is 265. That is pretty gosh darn close to west, so we're gonna roll with that. My rule is within 10 degrees is what you're after. If it's not within 10 degrees of any of these, I expect you to interpolate. Meaning if it falls at exactly 045 degrees, that's halfway in between 30 and 60. 60 is plus minus 0. 30 is minus 1, right? Because to get from here to here, we need to do minus 1. To get from here to here, we need to do plus. We need to break a pencil, and then we need to do plus 1, right? So, since we're within 10 degrees, we can roll with it. West, to get from west, which is 270 degrees, to get down to 268, we need to do minus 2. So we're going to do the same thing. For our magnetic deviation, we're going to go ahead and write minus 2 degrees. Once we've done that, the nice thing is things are fairly simple. Take your true heading, which you calculated earlier, of 258, and then I strongly recommend don't play games, just get a calculator out. Worst case, you spend a little extra time working on the calculator. So, 258 plus 7 is 265. Minus 2 is 263. So your compass heading is 263 degrees. That's all you need to do. That right there is the hardest part done. Now that you've calculated out all your heading stuff, that's, as we remember, your true course is where you are going. That's the track you're trying to fly over the ground. That's this line. Your compass heading is how you actually get there, what you fly based on the compass to actually end up there. Now we need to figure out how long it's going to take and how much gas we are going to burn. As we remember, I really hope at least one of you said that out loud. I'm going to be really sad if you didn't. But distance raptor, want to test my drawing skills? Distance raptor over time raptor equals velociraptor, right? So if we take our distance, which we measured to be, again, get out of the way, there we go, 30 nautical miles, so 30 nautical miles, divided by time, which we don't yet have, equals velociraptor, right? Velocity. We know that our velocity is going to be our ground speed. Don't let me catch you trying to use your true airspeed to calculate out your time. I'm gonna yell at you, and then I'm gonna laugh. So, our ground speed, which we calculated with the E6B, is gonna be 106 knots. 6 knots. A little bit of algebra is gonna look really cool when I speed this up for the video. It's gonna be awesome. Here, I'm actually gonna write it down here, so when I zoom in and make it really blown up and garbage and super low res, you can laugh. Did you get it? I hope you got it. What you should have ended up with is, now I gotta find some, there we go. I'm reaching in between some weird parts of the tripod. This is getting real awkward. What you should have ended up with is T, or your time, so we're clear, should end up being 0.28. 3 digits past the decimal is more than enough. I'm totally fine if you want to do 2. 2 digits past the decimal. Just remember your rounding rules. If it's over 5, add to the next place. If it's under 5, round down. So in this case, since it's 0.28301, whatever, we're gonna do 0.28 hours. If you wanna be smart, do this bit now and multiply that by 60. 16.98 minutes. That is as close as a gosh darn to T equals 17 minutes. And that is plenty close. Now life gets reasonably simple. Just take all that math you just did and fill it in. ETE means estimated time en route, and that's going to be in hours. That's important because that's for your fuel burn. We're going to be working with 0.28 hours, so 0.28 goes in there. For fuel used, so for your ETA, ATA means estimated time of arrival versus actual time of arrival. So in this case, I'm going to give you an estimated time of departure. So you're going to cross over that waypoint at a particular time. Let's say in this case, let's use right now, it's going to be 23:48 Eastern Daylight Time. Yay, convert that to Zulu. So for daylight time, it's 4 hours, right? So what's 23 plus 4? Math hurts. Sorry, I was just flying a jet. I used all my brain power on that. 23 plus 4 should be 27 minus 24. I'm just going to use a calculator. I'm not too big for that. 2, 3 plus 4 minus 24. That means that should be at 0348 Zulu. Now we calculated how many minutes it was going to take. We figured out it was going to be 17 minutes. So all we got to do is add that up. So what's 48 minutes plus, not minus, plus 17? We end up with 65 minutes. Hey, guess what? That's over 60. So we add to the hour, take one off. That means our estimated time of arrival is going to be 0405 Zulu or 0005 Eastern Daylight Time. Real world, you just do Zulu. Test questions might ask you for one or the other. They'll probably either give everything to you in Zulu and ask you to do it in Zulu, or they'll give everything to you in a particular time zone and ask you to do everything in that particular time zone. I'm doing both so you understand, but keep in mind it's mostly going to be Zulu. For your fuel burn, the good news is it's not totally challenging. You take your calculated fuel burn, which we determined to be 7.4 gallons per hour, multiply it by how many hours you're going to be flying. So if I go ahead and take 0.28 times 7.4 gallons per hour, that's going to get us 2.072 gallons. We can round that up to 2.1. But keep in mind for the test answer, they're probably going to want 2.072. So 2.072, and I'll also write in parentheses, 2.1 is 100% what I write in the real world. For fuel used cumulative, you can go ahead and skip that for this one. For fuel remaining, you can go ahead and skip that for that one. The ATA, if we remember, step 12. Yay! Check yourself. When you go and fly this thing for real, keep track of your actual time of arrival so that you can figure out whether you're going slower than you expected, faster than you expected, whatever it may be. And congratulations, you have now finished your first entry on a navlog. Way to go.
Yay!
You're a winner. Probably, I don't know. How'd you do? Now do it again.